Hello, welcome to your lesson on overlapping similar triangles. So our goals today are going to be to learn how to use what's called the side splitter technique and to redraw triangles that are overlapping so that we can solve for missing angles, or excuse me, missing lengths. And just so you're aware, there will be a bell ringer tomorrow that'll ask you to calculate some of the values similar to what we're going to learn how to do in this video. Okay. I want to make some observations here on these two similar triangles. Your triangles do not have these angle markings, so I'd like you to go ahead and add those in. And to note what we're observing here, we're going to say that on these similar triangles, one of the first things we observe is that the corresponding angles have to be congruent. And then in the picture here, we definitely can observe that. All right, so record that one. The second item that I'll have you document is that the sides all have the same scale factor. Okay, in other words, the sides are proportional. So what does that mean? Well, if you haven't finished recording, go ahead and pause the video and record, and then I'll explain what that means. So if they have the same scale factor, that means that if I look at each set of sides that match up or that correspond, if I write them as a ratio and divide them, we should get the same value. So I'm going to look at the 13 and the 16.25. And if I write that as a ratio and divide it, it gives me 0.8. That's my scale factor. So that means that all these other sides, when we divide them, the 12 and the 15, for example, also have that same scale factor, as do the 5 and the 6.25. Notice when we divide that, they all give us a value of 0.8, okay? Even if we went the other direction, if we put big over small, 16.25 over 15, oops, was it 15? No, 13. 16.25 over 13. Now, notice it's a different number, 1.25, but when we set these problems up, as long as I put the top on top of the larger on top of the smaller, notice we're getting that same value of 1.25. And it works on that one. So essentially that scale factor has to be the same on each of them. Okay. All right, now down below, this last concept before we actually do any math today, before we do any like calculations, I should say, is really kind of a big picture approach. And so what I did is I created two triangles that are similar and I stacked them on top of each other. And what you should notice is that this top angle here lines up, okay? And then the bottom edge, as long as I slide this up the side here, this bottom edge of the red triangle and the green triangle are actually parallel. So there's kind of a unique situation that happens on the sides that are split up by the parallel lines. What happens is these two numbers on the left, if we write them as a ratio, are actually equivalent to the two numbers on the right if we write those as a ratio. So I actually measured these out. You can record those values, and if you don't believe me, I'll slide the ruler over. So that green triangle has a length of 5, and I measured all the way down to the bottom of that line. So it's about 5, and then the next section, if I slide this down, starting at the bottom of the red, is like 1.7. Okay. And then the same thing over here on the left. The red segment on the bottom is 1. And then the top segment, it has a length of 3. So what happens when we divide this out? Well, let's just check. 3 divided by 1, that's pretty obvious. That's 3. But what's kind of cool about this is even though these other sides are different lengths, when you divide those two values, it turns out that now, again, it's off a little because I measured by hand, but that's pretty close to 3. And so what happens is these sides that got split up form a proportion that we can set those fractions equal to each other, and that's the relationship that will exist on all of them. Okay. Oops, this is from earlier. It didn't get deleted. Okay, so here's where we're at right now. I'm going to go ahead and do the 2 warm-up questions with you because I don't think we've done these since Algebra 1. So the skill you're going to see here, we're going to need for all of the work we're using this unit. But it's kind of like the robot questions where we cross multiply. So if you notice this first problem, I kind of set this up for you. We're going to take and multiply the parts on the diagonal. So 12 and x multiply to give us 12x. And then did you notice how I put x plus 1 in parentheses here? Well, that's because that's a quantity. And so we have to take 9 and distribute it to both of those numbers. And that's actually right where I left off here. So we got 12x equals 9x plus 9. And now we're just going to use inverse operations to get the x's on one side of the equation. So we end up with 3x equals 9, which means x equals 3. Okay, we'll do one more together and then you'll pause the video and you'll get part C checked. Okay, if I multiply these together, 8 times 2 is 16, and there's also an x, so it's just basic multiplication. All right, and then we're going to take 4 times the quantity of 6 plus x, so 6 plus x has to go in parentheses. All right, and then we're just going to distribute, so 16x equals 24 plus 4x. All right, and let's get the x's on one side, so I'm going to subtract 4x. And we end up with 12x equals 24. So x has to equal 2. Okay, so it's pretty much set them equal and then isolate your variable. Try part C, pause the video right now, try part C, bring it up to either whoever else is in the room, either Mr. Long or Mr. Cross, and have them check your work here, okay? All right, now that you've got that checked, let's apply that strategy. So here on number 1, this is kind of like the one we did over on the other page at the bottom here. We're just going to write the 2 fractions and set them equal to each other. Okay. Notice with the technique we're going to use, the x is located on, I'm going to say, the side split by the parallel lines. And I'm going to make that a little smaller so it fits in there. Oh, it's still too big, darn it. All right, we'll just do it like this. There we go. The side that got split by the parallel line. So I always think about it like this parallel line. Extend it. It creates like a fraction bar. So how does this work? Well, if I write the left side as a fraction, 4 over x, all we have to do is set it equal to the other side, 5 over 4. And we just cross multiply. So 5 times x is 5x. 4 times 4 is 16. How do you solve for x? Well, we isolate the variable, so I'm going to divide by 5. And if you grab your calculator, 16 divided by 5 is 3.2. All right, and then you're done with that one. Okay. Let's look at number 3. I'm going to rotate this, so if you want to kind of turn your paper so it looks like this, I just think it's easier when you can see those parallel lines on the top and bottom. Okay. I'm going to rotate it like that because I just think it's easier to see. Okay. That way I can extend my fraction bar. Okay. And then the numbers on the left, the 6 and 2, those numbers are going to go on the left side of my equation. So literally I just write those numbers as a fraction. Then we're going to do basically the same thing on the right. Okay, so I'm going to start with 6 over 2 because that side's a little bit easier. Now, the ones on the right, the bottom number is definitely an X. They have that labeled. Since they didn't label the top part, but they told us the total length is 10, we know that the top part would be basically the total length, which is 10, subtracted by whatever they used here. So like, let's say this was 3. 10 take away 3 would be 7. So we're just going to write it as 10 minus x. And then we just cross multiply. So 6 times x is 6x. And 2 times 10 would be 20. But remember, I have to distribute the 2 to both parts. So 2 times negative x would be negative 2x. And I'm going to add 2x to both sides. So I'll get 8x equals 20. And if we divide by 8, there we go. Divide by 8, we get, I already did the math on this one, so I'll just click on that. We get like 2.5 when you divide that out. Okay. I want you to try number 2 and 4, bring it up to a teacher to get your work checked. Ask questions when you have them, and then we'll see you back for the next last part. All right, now that you've got your work checked from the other questions, we're going to look at what happens when a variable is on one of these parallel sides. So when you see these ones with arrows, if they have something on the parallel edge, you have to redraw the triangles. Okay, so let's do our similarity statement first. Our similarity statement is basically what the two triangle names are after you separate them. So you can kind of see here, see how I'm just pulling that one off to the side. Okay. So the similarity statement is just naming this triangle. So I'm going to call it QPR. And then just make sure you follow that same pattern. So we went top, left, right. The other one would be QTS. Okay. Just like the other page, I'm going to extend my fraction bar so I can use my side splitter technique on the 10, the 2, the y, and the 3. Can you see how those are the sides that got split up? Okay, so I'm going to just write that proportion. 10 over 2 equals y over 3. And if we cross multiply, 10 times 3 is 30. 2 times y is 2y, and if we divide by 2, that means y has to be 15. Okay, that's kind of the easy one that we did on the front. Now, the other one, once we get it set up, is just as easy. We just have to make sure we're careful when we set the parts up. So once we redraw our triangles here, what I want you to notice is that the lengths of the triangles are really on this original picture. We just have to pick them off. So the left side of the orange triangle from Q to P, if you look over here, here's Q, here's P. That's labeled as 10. So QP has to have a length of 10. Okay, the bottom of the orange triangle is PR. They didn't tell us that length, but they did put an X there. So I'm going to put my X on the bottom of the orange triangle. All right, on to the big triangle. The red triangle, if I get rid of this orange one, we can kind of see that from T to Q is 2 plus 10 more, which is a total of 12 on that left edge. And then the bottom edge of the red triangle is 15. Okay, that's the hardest part. Now that you have that set up, all we have to do is match the corresponding side. So I'm going to match the left sides up with one color. And then I'm going to highlight the bottom sides with a different color. And when we go to write this proportion, some of you are really good at just picking these numbers off, but some people have trouble getting things turned around. I'm going to show you a strategy that probably helps if you get the items turned around. So I usually look at, like the yellow parts are the left edge, the green parts are the right edge. So I'm just going to put some labels down this side. And then So we have the left edge and the right edge, and we have the orange triangle, and we have the red triangle. All right, so I'm going to make like a little chart. There we go. All right, so I'm going to make like a little chart for my proportion. Like this. Okay, so when we fill this number in here, this number has to be the left number on the orange triangle. So it's kind of like a chart. The left number on the orange triangle is 10. Okay. On the red triangle, the left number is 12. All right. And then the bottom edges, the right, or it's not the right, I'm sorry. It's the bottom. It just depends which sides they gave you. They gave me left and bottom. So the bottom edge is X, and the bottom edge of the red is 15. All right, so these labels might help you if you kind of like, you know, you could even say like little and big triangle, because like yours aren't going to be color coded, but just make sure you distinguish which one's from what. Okay, if we cross multiply, 10 times 15 is 150. 12 times x is 12x. And if we take 150 divided by 12, I think that's 12, yeah, 12 and a half. So that means x has to be 12.5. All right, your job is to try number 2, show it to a teacher, and then you can start your homework until we transition to work with Mr. Cross today.